Hey friends, Doug Goodrich with Orion Cub USA, and we're still excited about our time that we spent with all of the aviation world at Oshkosh 2025. We learned and met lots of people, saw lots of things, and it was just a great experience from top to bottom. One of the most exciting parts was being able to meet and spend time with Kevin Hopper, the designer and builder of the Orion Cub from South Africa. Kevin's a fascinating guy, and it was great to get to know him. One of the evenings at Oshkosh, we sat down with Kevin at our campsite and went over in great detail a lot about the airplane's design and performance. And we captured a lot of great detail, which if you're interested in the Orion Cub at all, I think you're going to learn a lot from this video. We start out in the video by asking Kevin where he got his inspiration for the design. Take a look.
Take a model airplane and try and make it look different. And that was what I started doing. And some of them did work, some of them didn't work. And then it came into radio control modeling. Again, I always wanted to be different to everybody. So I designed my own airplanes. And I think it started from there when I was a kid. Not necessarily to be different, but to do things a slightly different way. And I think it started from there. I did in 2007, I did an airplane called the Teddy. We only built about 6 of them. Wooden airframe covered with fabric, Cub style. It performed really well, but I quickly realized that you're never going to sell an airplane with a wooden frame. Not in bulk, not enough to make it. It's more a labor of love. So then I went along and I started designing the wing in 2012. So the wing design I did in 2012, the first thing I was looking at is I wanted an airplane that could fly incredibly slowly, but it needed to be safe. That was number one. The top end speed was never priority at all. It was always low speed and good low speed handling. So I was looking for an airfoil section that would allow me to fly slowly, but with safety in mind.
Safety, not going to stall,
Correct.
Harshly drop a wing, that kind of stuff.
Correct. And I looked up a lot of wing sections, different sections, and there's thousands. And I ended up with the Harry Ribbit wing section, a 30 series wing section, slightly undercambered, and it sort of tickled my fancy. And I said, that's the one I want to use. And then obviously we size it to what we need. And bear in mind, it's only the wing section that we're looking at, not the layout, size of flap, size of aileron, and certainly not the wingtip. But it was a good airfoil, low airspeed, and it also had a fairly good high speed, numbers. It really worked well. Again, I wasn't worried about the high speed. I was always worried about what I would get out of an airplane that flies slowly. And the reason for that was I wanted to do rally and precision flying in South Africa, which is generally done at a fairly low airspeed. And you don't want to be looking out the window and wondering if it's going to stall. So I spent a lot of time. I used the SolidWorks program and I drew this thing up. And I spent a lot of time with the fluid dynamics side of SolidWorks to see how my wing was doing. The airfoil section is beautifully clean. It's a stunning airfoil section from the outset. I then sized the flap. Obviously we wanted to fly slowly. I originally designed a flap that would slide out, Fowler flap, and drop down. And I quickly realized that perhaps it's not a great idea for a bush plane to have all this rack and pinions and things, and I go, it's not worth doing all of that. So I went back and redesigned just a little slotted flap, which really works well. It does extend perhaps half an inch before it goes down, but it's not really designed to extend and extend the cord at all, but it's just the nature of it, where it's hinged. But it gives us a nice slot, and it allows the airflow to go over the flap really well. When it came out to the wingtip, I wanted again to be different. So first prize would have been to have the wingtip hanging downward, but I've got marks on my head from things that hang down, and I decided to go upwards. It's not the cleanest, but it's certainly working for us. We're re-energizing about the last 8 inches of the aileron right down into the stall. We're able to use the aileron, and the aeroplane just decides it's going left or right, even in the stall. So It's a practical wingtip. It looks pretty as well.
Yeah.
Um,
It's definitely unique. It's not Cub-like.
It's not Cub-like, and it was something that we could machine the plug on a CNC machine and make relatively easily. But it also does one other thing. We get effective span of an aircraft. If you take the typical Cub style airframe, it's got a 34 foot wing, but the tip vortexes tend to pull in towards the fuselage.
Rounded,
Yeah.
sloping down,
Yeah,
rounded shape.
but the airflow effectively gets narrow, so the effective span of your wing is not 34 feet. It will come in, and I don't know what it is, but you can actually go and watch videos of them flying through the mist, and you'll see it comes in. Where our one actually takes the vortex, and the way it's shredding it is outward, and we gain about 2 inches of effective span. So in effect, our aeroplane has got a 4-inch additional wingspan, and nothing's ever free. So we're not going to say, well, we bring you all the tip vortexes to the one point and we're going to get rid of all the drag. Not really. It just energizes, makes my aileron work, and it sheds mostly the vortex in one point. So it actually works really, really well.
And I know you were talking about some of the fuselage structure, kind of how you set yourself apart, because this is not just a go to the Smithsonian and download the Super Cub plans and copy it from there with a few modifications. This is a clean sheet kind of thing, and so there were some things you wanted to do different there.
Yeah. Well, let's start right up at the firewall. We need to support the firewall for the weight of the engine. So everything that we have is triangulated so that the entire weight of the engine, if you have a hard landing and the engine wants to go down, it's all brought back to one common point and taken up into the wings. So all the weight of that engine is pulling on the wing structure as well, right at the top. So we can spread the load over, I think there's about 8 different tubes that take the load, versus what I've seen on others where they are relying on some little tubes down at the bottom. It also gives us a nice common point. So I think we've got 6 tubes coming into one cluster, makes it nice and strong. It's very clean. We don't have to add anything, so we can go up to 200 horsepower, Lycombe's 0360s, in terms of weight. Power, not such a major problem. The power, we don't have such a huge P factor or torque factor that we have to worry about. We've got huge control surfaces. The rudder, I've never run out of rudder yet. Even with
have a nice big rudder.
Even with a 175 horsepower engine, I've never run out of rudder. So we got incredibly good control response at low air speeds. And when I say low air speeds, anything from 30 down to 20 miles an hour, because we can have the tail up at 20 miles an hour, put it over a little bit of aileron and top rudder, and we can run along on one wheel from as low as 20 miles an hour. So the response out of it is great, but without being overly effective, so that it becomes this twitchy aeroplane. So it's harmonized really nicely.
Yeah, I was going to ask you, what's the weight of the controls?
I've never weighed them. I never weighed them.
I just mean
they're very
force
light,
input.
very nice and light. I will tell you that our aileron and elevator probably feels like an RV7 when you fly. So it's nice and light, with good response. The only change that I've made from the prototype to where we're at now is I redesigned the ailerons, because I suppose I was naive at the time, thinking that everybody was going to have a 120 to 135 horsepower engine. And I'm suddenly realizing people want more. Do they need it? No, but they're getting more.
Absolutely.
And so
Especially in America.
they're putting in 170, 195 horsepower. And it's giving me a top end speed that I never envisioned. If you go and look at my calculations, everything was done to 110 miles an hour.
Yep.
Now we're actually doing 120 knots. So for the same airframe, I'm just a little bit concerned. We've never had flutter. We've dived it to V&E with the old ailerons, but I'm conservative. So I redesigned the aileron just with a balance tab in the front. So we've moved the spar back a little. It doesn't really change the way the airplane flies or behaves. It has, at higher speeds, made the aileron a little lighter. At low speeds, you wouldn't know the difference.
So one of your most notable differences between the Orion Cub and other bush planes is the aluminum wings. Do you mind explaining why you decided to go the aluminum wing route versus the completely fabric airplane?
from the beginning, I've been looking. My daughter was actually living in Canada, and I was looking at what they use. We call it a bucky. You call it a what do you call this thing? A truck. So we were looking at they use
A bucky. Wow, that's something.
I'm going to tell you a bucky.
A raptor bucky.
A bucky is the Afrikaans word for a dish.
Okay.
Now you can picture the back of the bucky of the truck. That's the bucky.
All right.
So these guys use these things as daily commuters because they're in the outback, wherever they might be. A lot of times they operating from unimproved strips, more times than not. And the feedback I was getting from them was saying, because of unimproved strips, if we shoot up a stone with a prop or the wheel, it goes through the fabric fuselage, out the other side, and they carry on flying, some duct tape, and off they go. But they don't appreciate when they go through little overhanging branches and they cut the fabric. Now they lose that lift and the integrity of the wing. They said, if we had an aluminum wing, a little dent, we'll live with that because the wing will still have its structure. And it led me to think, man, I can make a wing that is smoother, cleaner, tidier, and lighter by doing this aluminum with the spars. And it's so easy to make because we route the stuff out, we form them, and everything fits. You don't have this undulation on the wing, which is more drag. We've got a lot more strength out of the wing simply by having countersink rivets. It's where we're relying on the two skins and the dimpling to give us that shear load. And the part that I like about it is it weighs about 70 pounds.
Nice.
So it's nothing.
Yeah.
Do you use a layered spar design, or is it like one solid piece of aluminum like RP's used?
What we've chosen to do is an extrusion. So it's a single piece spar. Obviously made for the front and the rear, they're different spars. And our lift strut is also an extrusion. All 606 T6, 6061 T6. It was the simplest way of doing one, to layer it and to go and make the inboard a lot stronger than outboard is time consuming, and in our case a little unnecessary, because our wing loading is not that high at all. And the only thing that I've done is I've put doublers on the root, and I've put doublers at the lift strut, and I've put doublers where it's needed. For instance, we have a compression tube, which is a 4130 compression tube, and I've used that to set the pulley for the aileron cable and a bell crank at the back. So I've got a short aileron push rod from the bell crank to the aileron, and the rest is a closed loop system of cables. So the cable goes down the lift strut. So the aluminum, I got to say, is the aluminum is really a very easy way of doing it. So we know the material because we have it extruded for us. We do pay extra, but we get the chemical analysis of it, and we get everything. We get even down to how straight it is. And it is amazing how well these guys have made the spars. I have yet, out of 350 kilograms, I don't know, that's nearly 800 pounds, yep. I have yet to find a single strut that I can't use or a single part that I can't use. It's really, really well done.
That's awesome. So all of your skins that you are manufacturing in-house, correct? You have a router system?
Yes.
Can you explain that?
Yeah, we've got a CNC router system. We've tried to keep it as simple as possible. So we don't match hole drill the entire wing. We match hole the ends of the aileron, the ends of the ribs where they fit onto the spar, front and rear. And then once they've been formed, all down the side where the top or the bottom where the skin is going to fit, we haven't made any holes in it. We've allowed it, again, for the 51% rule, this works really nicely.
Yes.
Because there's a little bit of drilling and a little bit of measuring to do. So we put a black line down the center, put the skin on, level it at the top, move the rib until we see it through the hole that's already in the skin, drill the holes, click it on. It is the simplest way that I could ever come to build a wing on a table. As I said earlier, I can't make a flat table. I've tried.
So that way it allows your ribs and the holes in the wing skin itself to be absolutely perfectly aligned with each other. No mess whatsoever.
Yes, especially for the fact that we don't have air conditioning where we in the shop that we're doing the routing. So 5 degrees in the morning, possibly right up to 30 degrees in the evening, that skin will grow about 1/8 of an inch.
Yes.
So it's crazy. Now, when you're assembling it, we allow all the things to acclimatize to a certain thing. So we'll bring them in overnight. So whether they're at 5 degrees or whether they're at 10 degrees, it doesn't really matter. They're all at the same temperature, and they've all got the same sort of set at that stage. Once you start putting them together, try and finish the panel to the end. Even if you don't do the bottom, do the one side completely, and then we get a perfectly flat wing. Even with a temperature change through the day, it doesn't make any difference.
And so things like your glass and things like that, are you doing that in-house, or you what's like your windscreen and your side windows and things like that?
Right. What first of all we're using is a cast acrylic from Eurocopter. It's thin. It's a 2.5 millimeter versus a 3 millimeter, so it's slightly lighter, but it still has the impact resistance that we require. We've made the molds for the front windscreen, and I have a guy who molds the windscreens for me. We're not geared for that, but we get the same material from him, and we put it on a router and we cut it all out. It's got all the holes drilled into it. So one of the big things I see in home building is the guys are actually nervous of cutting plexi for whatever reason. So we've already done that for them, and the only thing you'll do is you'll take it, turn it over, and you'll chamfer the edges. That's all you're going to do, and then it fits perfectly. So there's nothing you don't have to go and measure anything. That was one of the things on the frame. Where let's talk about the rear window, side window. The frame is made, it fits onto the airframe properly, and we haven't drilled any of the holes into the frame itself, which is with a 6061 aluminum.
Yeah.
But we have them in the glass.
Wow.
So you mark them through and then drill them. Again,
That is
the 4130, after correction, the 51% rule in mind. That's what we're doing it for. So there's a certain task that you have to go and perform, and that's really what it boils down to. But you don't have to go and space a hole. It's there. Line up the window, drill the holes, take it off, deburr, clean it up. Then we fit everything before we go painting. So everything's done. We take everything off the frame. We'll go and Aladdin it, or we'll go and prime it, and then we'll put it back, and then we'll spray the frame or the primers that we need to while it's on the frame, but very little gets sprayed on the frame, so you don't have to worry too much about all the nicely powder coated frame getting overspray, because it's really, you can do it off the frame. Once it's fitted, put it back, rivet it on, so it's very quick and very easy.
And speaking of the frame, your steel frame, TIG welded, and that comes painted, powder coated. What are you doing with the frame itself?
Okay, let's start off. The frame is all 4130.
Yep.
We TIG weld everything, so each tube is laser cut. It's put in, it's welded. We then send it off to powder coating, and we've got a good relation with the guy. He uses a very, very fine powder, but under high pressure. So he stress relieves our frame to some degree by just having this, pretty much what they do at shot peening a propeller. That constant bombardment of tiny particles is stress relieving our frame. They then do a phosphate dip, take it out. Don't know if it gets dry or whether they force dry it, but they powder coat, and we get it back from there. Once it's back with us, we actually go and drill 4 holes in the frame. All our tubing is interlinked with little gaps, so we introduce a 30 milliliter injection of corrosion X that creeps up through our frame. So the whole interior is corrosion X, and then we put a sealed rivet and close it up.
smart.
That's where I was going.
Yeah.
What do you do for internal corrosion?
That's what we do.
So to get back onto the windows, just based off my experience with the Sling TSI and the Sling High Wing kit, fitting the windshield is an entire day process for one person, with cutting it out and sanding it and getting it to fit perfectly in that frame before you can ultimately glue it in.
Yes.
Are you saying that your windshields come out of the box and fit phenomenal?
Not the windshield. We're doing
Yep.
the side windows for you. So
Okay.
there's the 4 side windows which are fitted perfectly. The front window has been trimmed. Again, we're thinking about the 51% in mind. There's minor trimming to do it. You
Understood.
really don't have to do a lot. You'll actually find a felt tip pen's gone run around and given you a very close idea of where it is from our mold. So we give you an idea.
Awesome.
It may not be 100% perfect, but you can trim basically up to that line, flat it, clean it, smooth it. Some people wick it with a flame. I don't ever bother. I sand them nice and smooth, and that's what we do. But there is certain amounts of work that we have to leave in order for it to get it into the 51%.
Yeah. So the side windows and the door windows.
Yes, all
They
done.
are
They're done.
really.
Yeah.
That's fantastic.
So easy.
That is phenomenal.
How are they primarily fastened in? Are they glued in? Are they screwed in, riveted in with like a trim ring? Like how are the windows fastened in?
All the side windows, we fit mark on the inside. We take Sikaflex primer, and we don't use the Sikaflex adhesive. We don't find it necessary. We just use a normal silicone. Then I do have, the holes are there for rivets, because I've blown out a few windows, not out of my aeroplane, but out of Cubs, by doing side slips and being very aggressive with the side slip. And I've blown out a bunch of windows.
Wow.
And it's not nice to go and say to the owner, I'm sorry, I need to give you some new windows. So we've chosen to do it that way. The silicone will actually hold the window in. You don't need rivets, but we use a very large flange rivet, and the hole is drilled oversized, so for expansion and contraction we don't have an issue. But we're using a fairly soft rivet. It's not an AVEX rivet, it's a fairly soft, but it's been anodized black, so you don't even see it, but you'll have a nice black edge to the window, and the rivet is in that black edge. And then between the back and the front windows we normally mask it off and we paint it black, so you'd end up with this almost wrapped around from the front, from one side to the other, black window.
Cool.
Our windows are tinted grey, most parts.
Oh, they are.
If you really want, we can do other colors, but the brown, what they call bronze, is what we go for.
Oh, very
Yeah.
cool. And it is still a pulled rivet.
It is a full rivet. Yeah.
Awesome.
Yeah. It's just a large flange rivet, because we don't want that point load on a window.
Understood.
So we use I think it's a 3/8 head, and it just all we're doing with that is making sure that the window doesn't come out.
Yes.
If Kevin does a side slip.
That seems very simple.
And what do you have over top? I mean, I've seen pictures and stuff, but describe what you've got over the top between the wings.
On the top we've done the same. We've also got a little recess for the window. It'll be machined. We're not going to cut that one to the exact dimension again, not just for the 51% rule, but because all the frames are ever so slightly different how they pull with the welding.
Of course.
So the recess is there, but it's a straight cut. It's very simple, and it's a double dark window. In other words, it's the same bronze color, but it's darkened, so you don't sit in the sun. It's much like having a film on the window, but you'll sit inside and you can still see out really nicely, but it's dark.
Even at night, that's
Even at night, no problem.
Awesome.
Yeah. I find myself looking through the top window on many times on final approach. You just pull and you look through the top window and you find, oh, there's the tree that I know, and you can keep turning. So it works really well.
awesome.
Do you think there's room up there for a Starlink antenna?
Depends how big it is.
They're about like this.
How thick is it?
Not that thick.
Well, there's space because we've got the two tubes that are stabilizing the front spar going to the back, which makes the front spar is 127% stronger than it needs to be, not 27%.
Wow.
127%. And the reason was I had already got the design, and I did the math and I realized it was stronger, and then I sent it out and it gets analyzed again for me to make sure. And the guy came back to me and said, wonderful fuselage, but can you not make that thinner? I said, no, I've already designed it in, and it's good strength. Just leave it there.
Yeah. And then I wanted to ask about like the side doors, windows, things like that for openings, and also baggage area, what you have. I know Eddie, a week or so ago, your partner in South Africa, Eddie, posted a picture of a loaded up baggage area, which I'll try to clip out of WhatsApp and put into our video here. But it looked like there was a ton of stuff back in there.
You can fit a lot in the back. We got the door on. Let's talk about the pilot side, which is the right-hand side for entry. The top door swings up on a little gas strut.
Okay.
And then the bottom door swings like a car door, open and shut. We've chosen to do that because I've lowered the sill from a Cub size where people battle to get in. I'm about 2.5 inches lower than a Cub, and probably nearly 3 inches further forward than a Cub. So getting your feet in, I have a knee problem that I can't get in, and I can get in quite comfortably. I can even move the seat back and get in. So it's fairly conventional. It has a spring clip with a handle to close it. The doors can be opened to about 70 miles an hour. If you want to go faster, you can either take the doors off. It's simply a case of pull 2 pins out and the top door will come off. Or you can ask us. We can make a latch, which we've done on ours, and we can go to 100 miles an hour with the doors open. Generally found, when the doors are open, you're not going to be doing that speed. You're going to have it open for a reason. And it's not just because it's hot, it's simply because you want to be able to see and you want to be flying slowly. There you're going to probably be doing 55, 50 knots, or miles an hour, correction, 60 miles an hour. So we're good with that.
Because at the higher air speeds with that door,
With the door
you're getting a
lot of air.
inside.
Then the baggage door is not on the prototype, but we do have a fair-sized baggage door, which is, the lock is actually put in upside down so that it cannot rattle open. So you have to lock it to unlock it and unlock it to lock it. But it's simply so that the latch doesn't inadvertently open, that your baggage door goes open. But it's a fair size, so you can put a fair amount through there. The other side is open the door, pull 1 pin, take the rear seat out completely, which takes you all of maybe 30 seconds, and put your gear in and put the seat back. So it's really, really simple. It's 1 little pin that holds the seat, and the only reason for the pin is that in turbulence, if somebody's sitting on it, you won't have a problem. It's when you're on your own, you just don't want the rear chair to float around.
On the topic of things being simple and being removed with pins, how easy are the wings able to come off?
I think the wings come off very easily. They go on very easily. There's 2 main bolts, one in the front, one at the rear. And then we've got the 2 lift strut bolts. We've got, in the front is the cable going through the bottom of the strut, and at the back is obviously the balance cable. So you'd have to take those off. And then of course there's fuel lines that will come off, because the wing has never been designed for folding or quick removal. It shouldn't take you more than about 45 minutes at tops to take the wing off.
Yeah, that was my main question. Like, is it designed to be a quickly removed wing, like a Vans RB12, or is intended to be there?
Because we've got quite a bit going on in the wing in terms of the lighting, in terms of the aileron cables, in terms of fuel tanks and the fuel feeds. It's never been designed to take off quickly, but it's not a huge mission to take off. It's a case of taking a few fittings off to get, obviously you would have to end up draining the fuel tank because it's never been designed for that, but it's certainly not a mission to take off at all. Yeah.
So when do you think you can get me some kits here in the United States?
We're really hoping that you'll have them before the end of the year.
All right, awesome. Fantastic. And the plan is to have, will be my demo playing here, and hopefully another kit coming into the United States with the at the same time. So
we're trying
one on the way.
We're trying for a third one in there at the same time.
Okay.
Because it just amortizes the cost of the transport, so it just makes it more sensible. And also, you're going to sell it. I can tell you now, when you put that there and the guys see it and they see the price, they're going to say, I want one, and you're going to say, there's one.
Yeah.
Not
So-
to mention the performance.
Yeah,
So
exactly.
what numbers exactly are you seeing via like takeoff, roll, cruise, climb rate, stuff like that?
We were trying to work out your feet in inches this morning, but I think we're under 40 foot for a takeoff,
Yes.
which is on a non.
With which?
That was with a
What,
915.
915.
So the
So-
916 may do it a little bit better.
Mhm.
Again, a lot of pilots will get shorter or longer takeoff based on their skill. It's as simple as that. People ask me, what is the crosswind component of that airplane? I personally have seen 23 knots crosswind, directly crosswind, and I never had a problem.
Yep.
My test pilots look at me and say, well, so what's the problem with that? And I'm going, well, maybe that's the end of my skill level. That's why I'm not a test pilot. But I never really had a problem at all. So she gets off the ground, really controllable at low speeds, as we said earlier. And she flies away. So you can fly away with full flap if you want to. You don't have to dump flap when you're close to the ground, because that's get the airplane up, get it flying, and then worry about the flap later.
Yep. And we've got a video of the yellow
Yes.
Orion Cub in Australia competing at a STOL event there. And again, here we'll try to clip it and add it to this video so people can see its performance. And that airplane was the 915, as you were saying, and it just shows how quickly that thing just gets right off the ground.
That was a 915, and also remember it's an unmodified version of an airplane. That's what you get if you buy an Orion Cub. We're not enhancing its performance to get off at a STOL competition. We went there more to show the people what the airplane looks like than anything, never expecting anything to get on a podium. But so much of the competition that we looked at, the airplanes that I thought that were going to be our competition didn't really feature. So I was quite impressed at what the guy managed to do. He had very low time on the airplane. We've subsequently found out that by keeping the stick neutral, having full flap and full power, you can actually get off ground in 3-point attitude, slightly less than what you saw in the video. But it's an unmodified airplane. We don't have wing fences. We don't have vortex generators. We have nothing. It's nice and clean, and the engine, the airfoil is good. A good airfoil doesn't need all those appendages. Would they make a difference? Probably. But would it be worth the effort? I don't think so.
Yeah. When you design it so it does so well, that doing vortex generators and slats and all of the different things that you're seeing on some of the real high-performance STOL airplanes is, like I say, the cost-benefit analysis. You're just not going to get that much more out of it because it's so incredibly capable. And then you start paying a cost on the other side, usually with speed and things like that.
Useful load.
Useful load, more weight to it potentially. So
anything that you add takes off your useful load. The guys are asking me how much fuel, so we've got 40 gallons. Oh, I'd like more. For what? Where are you going? Really?
And especially with the 916 sipping fuel at 7.5 gallons an hour.
Absolutely.
But I'll show you this story. One of my friends has a Scout, and the reason why he bought that airplane was because of if I recall, I think it has 60 gallons or maybe even more. It has large fuel tanks, and that was the reason. So in America, there's always going to be these unique things that make somebody want something more than the other. But I don't disagree with you.
But I'm going to give you an answer.
Okay.
He could have bought our airplane still, even with our 40 gallons, because I have another 110 that I can put in a belly pod underneath.
Well, there
you go.
Yeah. So it's such a new airplane. I mean, we just haven't had time to
Absolutely.
field a lot of these questions and see what people will be looking for. So we were talking about stall performance, things like that.
And fuel tank capacity.
Yeah, the fuel capacity of it. Well, and the thing is, with on YouTube here, if you're watching and you have questions or you're wondering about a certain option or will it have this or that, feel free to add that to the comments here. We'd love to start to field that stuff and see what people are interested in. So one of the things that people always wonder is about cost, and we've talked a lot about that. We're not going to get into numbers specifically on this video because who knows how long the video will last, and numbers change, especially in this day and age. So I just want to say, if you're curious about what it costs, we at Orion Aircraft USA, we're going to try to be very open with the costs, and so we're going to put it on our website. So go to orioncubUSA.com. And we'll be as open as we can. Understand at this point, as we haven't even got an airframe to start to put together here in the United States, there's a lot of questions and a lot of things that we've got to figure out here in the United States side of things, and just so that you have an understanding of what we're doing here. So Kevin's going to be sending us airframe kits, but there's still a lot of things that would typically be sourced here in the United States that just doesn't make any sense for Kevin to buy, ship to South Africa, ship them back to New York to us. And so we're going to be adding a lot of the things like wheels and brakes and avionics, engine, propeller, shock options, tail wheel options, all of those things we're going to be doing here in the United States, and we'll come up to speed, I think, pretty quickly on figuring a lot of that stuff out. But if you really are interested in an Orion Cub, the thing to do is call me, get in touch with me, and I'll go through and I will price out a custom kit for you, so that you know right up front what one of these things is going to cost. It's just, do you want Acme struts or Shock Monster, or do you want 26-inch tires or 31-inch tires, and those kinds of things, and we'll figure that thing out, and we'll get more and more sophisticated with our website, so you can kind of point and click and do all of that. So give us some time to kind of get our legs under us. But the big thing with me is don't be afraid to call. I love talking with people, and if you're interested in the Orion Cub, we'll be keeping you up to speed on our social media, YouTube, things like that, and we'll be doing a lot with our website.
One of the things I wanted to ask is, obviously being from South Africa, and from my understanding, you guys don't have nearly the infrastructure that we do in the US, and you guys use planes to get from location to location, especially in the outback. With that in mind, have you guys made any changes to the design that's easy to fix on the fly, or easily repairable in the field?
Right now, the only change that I've made to the actual initial design was changing the ailerons because of the speed. Everything else, we've got 430 going on to 440 hours in a flying school environment with our aircraft, in the prototype, in form of prototype. We haven't had to change anything, but we've monitored every 50 hours.
Which is very impressive.
So
yeah.
we've done nothing from the first day. It was actually quite a fun story. The test pilot, on the day, we briefed, this is what you're going to do, up and down the runway until you feel comfortable, and then you'll do just a little flight until you feel comfortable. And he went tail up, down the runway, turned around, tail up, halfway, took off, and the next call I had was an hour later, and he said, I've got to land. And I said to him, well, what was the problem? Or what's going on? He says, I've got a meeting. And on the first day, we flew 3.5 hours, which is really unusual for a brand new design, brand new airplane. And quite honestly, we have changed nothing. From the first day, the cooling's worked, the ailerons have worked, the flaps are working, the elevator's working, the trim is working. One small issue that I made myself is putting a spade terminal on. We used heat shrink, and instead of pushing it onto the heat shrink, I put it next to the heat shrink. And while we were demoing, there's no trim, and you go, okay, that's a bit of a problem. But it is, we flew all the way back like that, landed it. It is not a pitch-hungry aeroplane. It's not a trim-hungry aeroplane in any sense, even if you've got people in the back. There's definitely a difference with a person in the back, but if you're trimmed up with the guy in the back and it goes wrong, just fly the airplane. It really doesn't load up that badly. The big difference between flying solo and with somebody in the back seat is when you fly solo and you apply flap, not so much in the cruise, but when you apply flap, the nose drops and you have this panoramic view. You don't even know there's an engine involved. It's an incredible feeling.
You've got some ideas for some other types of, or basically a two-seat side-by-side. Tell us about that.
Very simply, we're going to do, when I get back from the States, we're going to assemble our prototype side-by-side. It's from the side view of the airplane, you won't know the difference. It's only if you look at it from the top or the bottom that you'll see it's wider. We're using the same wing, we're using the same landing gear and the same tail surfaces. So the big difference is really the cockpit. We're going to widen it. It's going to be about 1/2 inch narrower than an RV-10 inside. So it's a reasonably roomy aeroplane. We're not worried about the ultimate performance because guys are using a 916, bearing in mind it's a bush plane. So if we can still do around about the 120 knots or 115 knots, I'm going to still be impressed with what we get out of it.
Absolutely.
But that's the biggest change that we're going to do is widening the fuselage. We will restrict the aft limit of the baggage simply because we've got so much baggage at the back. And we're going to have a little lock-up cabinet at the back and a few small changes, nothing major, but that's progression of how we go forward and small things. The big question for me right now is, do we have a center stick or do we have 2 sticks on the side, and I saw an airplane today that you could have all 3. You could have a center stick, and I don't know what you're going to do with the center stick, but it's the way it is. So, there's a few things that we need to look at and iron out.
Okay.
What is the reason behind? What's the idea behind that's driving sitting tandem and sitting side by side?
Originally, I designed the airplane as a tandem because I very, very rarely flew with anybody in the back. And then when we did it for the slow flying and the rally and precision, it's nice to have the guy at the back who's your navigator. He's not looking out the front as much, he's looking for points and he's giving you time. And he can still see over your shoulder, he can still see very well. But to get to a common point, the parallax error is so small over that distance that when he says go, it's the right time. And it's easy for them to see out either side. So that was one of those. And that was the main driver for me, because sitting in the middle of my airplane was really nice. I was alone all the time. Now we've got many clients coming along and saying, I'd love to have a tandem. Correction, I'd love to have a side-by-side. Tandem is great, but my wife doesn't want to sit at the back. My girlfriend doesn't want to sit at the back. So we said, all right, it's a small change to a fuselage. And then when you look at it, the change is actually just the fuselage. Very little else changes. We keep the wings, so the wingspan increases by whatever we widen the fuselage.
Yeah.
We still keep the same tail surfaces. We can still use the same landing gear. We're not changing the weight of the airplane by much. It's going to be a little heavier because the tubing's a bit wider. And there's a little bit more plexi and there's a little bit more cowling. But the big driver is very simple. Most people want to sit next to somebody when they're flying.
Yep. And describe quickly the changes you make to the airframe in order to handle like a heavy Lycoming or Titan engine versus the Rotax.
We have two options when it comes to the fuselage. One is a foot longer than the other. Obviously, the heavier engine needs a little bit more weight at the back, so we've added the extra foot. But it's not just plain cut off and made shorter. We've actually tapered the entire fuselage. We have photographs which will show you 2 aircraft flying together. One is a long version, one is a short version, and nobody knows which one is which. And we purposely put the long version in the foreground, which makes it even worse. And I've shown many people, and they don't know the difference between the two. They cannot see it. So the shorter version is it's purely CG. It doesn't change the cabin size. It doesn't change the weight that we can carry. It's simply a CG issue that we've moved back slightly. When you fly the one or you fly the other, they have the same feeling. That extra foot that we've got really doesn't matter because the CG is sitting in the same place. And that's really what it boils down to. We try and keep the CG as far forward as possible when it's empty, simply because it's a tandem. We put everything that we put in behind us and the CG progressively moves aft. So we set them up with a Lycoming, which is, I suppose, 30 pounds extra on a Rotax 916. So just to offset that, we've had to go and lengthen the fuselage.
And you're saying so far what you found the sweet spot for performance wise is Eddie's with the 135 horsepower edge?
No, you're wrong.
No?
Eddie's got 175 edge.
He's got 175.
Yeah.
Okay.
Eddie's got 175
That's
edge.
right, he's got the monster.
The whole design, if you go and look at this design and the drag and the numbers, between 120 and 135, or 130 actually, is the sweet spot on that airplane. From a weight point of view, from what you can carry, the speed you're going to get out of it, the fuel burn, it's a really great position to be in. But now with the 916 that uses a lot less fuel than a 915, it's now becoming feasible to put that in. So we still got the range, but we've got that extra power, and I think we have that 160 for takeoff up to 18,000 feet. So it makes for where we're flying in South Africa on a daily basis. In the summer, we'll have between 8 and 8,500 density altitude. And we find it absolutely amazing that we're teaching people to do tail wheel conversion with a 100 horsepower engine. At that density altitude, we estimate 76, 78 horsepower, and it still flies unbelievably with 2 people on board. And it's so easy when you've got more power.
Yeah.
Yeah, and that's the thing. I remember when I first saw your website, the OrionCub.com website. A lot of pictures of the prototype, and you guys were saying your density altitude is what in some of those videos that are there?
Well, it can go up to 9,000 feet quite easily.
It's high. So you're seeing the performance of a plane. You can say, well, that's not that impressive, but then, well, wait a second.
It's at 9,000
It's a
feet.
carbureted 100 horsepower Rotax at 8,000 to 9,000 feet density altitude. It's doing pretty well. So it's a little misleading.
Yeah. We have high density altitudes no matter where we go inland in South Africa, and we will have takeoffs that are 130 feet, 150 feet, and you guys at the coast go, this thing doesn't perform. But you also don't understand the density altitude and the heat that we got. So it makes a huge difference. And the performance we're actually getting out of 100 horsepower is amazing. We can cruise at 100 knots.
Wow.
So it's pretty good. We can slow right down to, our stall on every airplane so far has been 26 to 27 miles an hour. So I think our brochure shows 27. Again, add a little bit of power and we can bring that right down. We can fly it at 20 miles an hour, no problem. No dropping of a wing. Doesn't do that at all. Just carries on going straight. We have some little party tricks when we show people how well it works. We bring it down to about 45 miles an hour and do a 45-degree bank and just pull it around. The airplane wants to do it and the pilot doesn't.
So steep turns and slow flight, huh?
Absolutely.
Yeah, that's awesome.
And safe. What you will find when you fly the airplane is it loads up nicely. So I've done that on purpose for when you're flying low. You use the aileron, and the further you get into the turn, the more resistance you get to it. So it's still there and you can still use it, but it wants to feed back. So if you at any point got to a point where you feel uncomfortable, just relax the pressure and it's neutrally stable, and she'll just, well, rather stable, and she'll want to go and fly in a straight line.
So with your density altitude being so high, have you guys seen a real reason to push for the turboed Rotaxes versus, the 912 ULS?
Customers push for it, we don't. It's quite simple. We would be happy to do the 135, which is turbo. It's a 912 with a turbo on it. It's a great engine, still gives us our 2,000 hour TBO, and we've proven it in the school. It's great, lots of power, and turbo definitely at those altitudes work. So if anybody wants to put a 916 in, you're just going to have that benefit. You don't have to use all the power. You've got a power lever. You don't have to use it. You could take off at half power. It makes no difference.
Yeah.
But the time on the ground, it depends where you are. It depends what you want to get out of. At high density altitude, really nice. More power. My test pilot's got it down pat. He says, lots of power is good. More power is better. And too much is just right.
So for people that want to go fly in mountaintops and stuff like that, though, you have seen a difference with the turbo, especially at those density altitudes.
Absolutely. The turbo
Awesome.
makes the difference. Whether it's a 135 or 915 or a 916, the turbo really makes the difference.
Absolutely.
The airfoil obviously feels the density altitude.
Yep.
But with an engine that's putting out a bit more power, it really does make a huge difference. Getting off the ground, your landing roll is obviously longer and your takeoff roll is longer, but definitely with a turbo, there's no doubt it's going to get off the ground quicker.
And what was your landing distance? Because I know a lot of people are going to want to hear that.
We do it in about 45 feet,
45
somewhere
feet.
around about that.
So takeoff about 40, landing about 45.
45, yeah. It's going to depend a lot on the pilot.
Yep,
It's going to
of
depend a
course.
lot on the
It
braking
always
system
does.
that you install.
Yep.
So if you install a really cheap braking system, you're not going to get there. But certainly there's a pilot skill involved.
Of course.
Yep, absolutely.
If we think the average pilot, if he does it in 100 or 225 feet, it's still really good. So whether you can do it in 45 feet or not, I know that I've landed across our runway in Krugersdorp. Basically, we have a 9-meter runway, then we have a small piece of taxiway, and our taxiway is, 4 meters wide. So I've landed across, I'm going to guess, it's probably 30 feet.
It's less than 50 feet, yeah, which is incredible. So, and what altitude was that at? Density
That's
altitude?
5,500 feet
Exactly.
altimeter. Density altitude about 8,000.
So the Binghamton Airport, it's what I call a big boy airport. It's a
Class Delta.
Yeah,
Yeah.
I mean, we have airline service there and everything, so they have all the regulations and things that they have to comply with. And I told the airport administration the other day about becoming the U.S. distributor for Orion Cub, and they were excited about it all, and they're very supportive of our operations. And then I asked them, hey guys, you ever think about a grass strip here? And they were like, oh no. And it's like, oh yeah, we don't have space for that. And I'm like, you know,
It would need to be very long.
I was gonna say,
Exactly.
you certainly don't need a
It may
lot.
be rules that keep us out of there, but we've got some other grass strips in the area. But we've got a few spots around the airport that maybe I can talk them into to letting us use. We'll see in time. I understand they have a different set of rules than
You might be able to get a discount, and you say to them, I only want one white line to take off, please.
Yeah, exactly.
I have some thoughts about that too, with it becoming untowered after a certain time. So
Yeah, that would be interesting.
yeah.
We'll have to see. It'll be interesting. I mean, we have long runways and things like that, and I remember pointing out to these guys when we first started talking that guys, they roll out of their hangar right onto the grass. I mean, we have acres of blacktop in front of our hangar and things like that, so it's definitely a different world there, but there are some grass strips around for sure that we can get to, and we're looking forward to being able to offer anybody who wants an Orion Cub the complete package, not just the airplane, build assist, paint, all of that kind of stuff, avionics installation, very typical. But I've owned a flight school for a long time, and one of my flight instructors is already a tail dragger, proficient flight instructor, and we'll probably work with some others, other flight instructors that are, and so that we'll be able to train people if they're not tail dragger proficient.
What is he flying at the present moment as a tail dragger?
A Citabria.
Okay, that's
Yep,
good.
Yep.
that's
Yeah,
good.
so it's probably a trickier airplane.
Oh yes,
than
very much so.
than the Orion
Very
Cub.
much so.
Yeah. When you're landing, does it have much tendency to try to ground loop or anything like that? Tail loop,
I've never seen it try and do anything to me other than go in a straight line. It teaches you nasties though, because it's so much fun and it's so over controlled at low speed. I've never been one to have the tail up and then go, oh, let's go and get this thing on one wheel. Well, unfortunately, I find myself doing that now, so I'm saving my tires.
All right, so I hope you enjoyed the time with Kevin and learning about the Orion Cub as much as we did when we got to sit there and pester him with questions about the airplane. You can see that it's a well thought out design, and we're really excited to be bringing it here to the United States. We'll be seeing our first kits arriving at the United States at the end of 2025, and we'll have our demo plane flying in the spring of 2026. So follow along. We're going to be doing more video and putting more information out there on our website, orioncubusa.com, and posting more YouTube videos and things like that as we build along. So if you have any questions about the airplane, our contact information is all over orioncubusa.com. And you can reach us at doug@orioncubusa.com. That's my email address. Feel free to reach out. We'll answer any questions that you have and kind of keep you up to speed as this new airplane comes to the United States. So thanks for watching. Appreciate a like and a follow, and we'll see you on the next video. Thanks.